Alright, so here's going to be our notes on force. I'm going to give you options of watching my notes and watching other videos to answer some of these questions. So I guess we'll get started here. So we've been talking about motion and measuring motion and things like velocity and acceleration for the most part, and working on developing a car to measure those things. And our next question is, well, what causes that? What makes something have velocity and what makes something have acceleration? Well, the simple answer to that is a force. And usually in science, it may not be perfect, but they call a force a push or pull on an object. And, like if you have a box, hopefully we'll draw I can't draw very good, I'm just trying here. But so when you push on that box, you push on it, or you could even put a rope on it, and you could pull this way on the rope. And by applying that force, you then cause that box to move. Okay? And it just causes a change in motion. And the one thing a force can do, it could cause something to move, like this box which is sitting here, doing nothing, and then you come along, you push on it, or you attach a rope to it and you pull on it, and it begins to move. So initially no motion, you apply the force, it starts to move. And if it's moving, sliding down a ramp or whatever, you can then apply force against it. You can cause it to stop or the motion to end. Or if it's moving, you can apply a little force to it and cause it to go faster. Or like if you're in a car, you can apply the brakes to it and you can cause it to slow down. So forces really act in different ways to affect motion. Okay? And really, if something is moving, it has something to do with this term right here, equilibrium. And equilibrium, if we went back to this original box here, let me see if I can erase. We go back to this box where there is no force on it, then we would see that it's really in equilibrium, that all the forces acting on it are equal. Okay? And really, if nobody's external force isn't being applied to it, the only force we have on it is gravity. And then we have some other force, we'll talk about that later, the normal force or force of N. So really, when no person is putting an applied force or an external force on it, the only two forces acting on this are the force, normal force, force of N, and force of gravity, F of G. Okay? And so if it's not moving, that tells us, or if motion is not changing, it's in equilibrium. Because it can be also that if an object is moving at a speed that doesn't change, so a constant speed, then we know that equilibrium is also present there, because it's not slowing it down, it's not making it speed up, it's keeping at a constant speed, so we know that all forces are equal. So this applies to no motion, right here. It also applies to constant motion. And you don't want to get, really it's constant velocity. Constant acceleration means it gets faster and faster, and that tells you also that there's an unbalanced force on it, and equilibrium is not present. Let's see if I can write with this. So constant, I'm just going to call it V, velocity. Examples of forces that you could have are friction, and friction is just the interaction between the object and the surface. So this box here, if we had it on different surfaces, like if we had it on ice, it would be easier to push. If we had it on gravel, it would be much harder to push. And we kind of call that friction, and some of that depends on the box, maybe the object itself, and the surface that it is on. So two main types of friction are static and rolling. And static friction is the friction you must overcome, or must overcome to get an object moving. And if you've ever noticed, the amount of force it takes to overcome getting something to move is pretty great. But then once that object starts moving, you don't have to apply as much force. And then rolling friction is when something is already in motion and the interaction between the object and the surface that it is on. And also we have air resistance as well. So if you are on a cliff and you throw a rock and it falls down, you have little particles here in the air, and they bump into this rock as it's falling, and they cause air resistance, and they cause it to slow down slightly. Okay, so let's keep moving along here. Okay, another force is called gravity. I'm going to erase this here. So gravity, as we talked in the box above, is the force that exists between all objects. Many people don't realize that, but whether you're a person, whether you're a planet, whether you're whatever, a star, whatever it might be, you have gravity. And it's something that's observed in nature, but it's really based on the size of the object and the distance they are apart. So some people might say, well, we have gravity, why don't we attract things to us? Well, the problem is that gravity is present in all things, but also the idea that it's also based on their size. So if you're comparing the object of a person and comparing it to the sun, which you can't even compare to size here, the sun is so much larger, the earth is so much larger, the moon is so much larger, and all those other objects are so much larger than a person, that their effective gravity is so much greater that we don't even notice our own effective gravity. And we're going to talk later about gravity. And then there's the applied force. And the applied force is, when a person comes along and applies a force to an object, either by pushing on it, or by putting a rope on it, or pulling on it. A unit for force is the Newton, and it's really kilograms times meters per second squared. You don't have to worry about that. And just keep in mind the Newton when you're going over problems. And you put an answer down for the amount of force that you include Newton. And then also we have a couple more here. So we have inertia, also tied into this idea of force. And this is the idea that all objects have the tendency to resist motion or change in motion. And it's based on this, the amount of this is based on the mass. So if you have a giant box like this that weighs 1,000 kilograms, let's say, its ability to resist motion is much greater than if you have a small box that weighs 1 kilogram. Okay, but all objects have this tendency. They tend to stay not moving, or tend to stay moving the same way. If you've ever been in a car and you suddenly stop, your body lurches forward because it wants to continue moving, even though the car you're in is stopping. And that's inertia. And then the law of inertia, which is really Newton's first law, is this idea that objects at rest or in motion will remain that way unless acted on by an outside force. That's Newton's first law. And we're going to learn more about that one, but this is your introduction to force. And just remember, it's a push or pull on an object. Equilibrium is something that's associated with force, and if something is in equilibrium, it will either not be moving or its movement will not be changing. Force can cause an object to move faster or slower, can cause it to start moving if it's not, or it can cause it to slow down or reduce in speed if it is. Friction, examples of forces are friction, gravity, air resistance, applied forces, and the unit for force is a Newton.